Welcome back to the workshop for one last video on the knapsack problem. So we've taken a look at the knapsack problem itself, and we've taken a look at sets. And now we want to, again, bring those two things back together. We're not going to be able to bring them together in a fantastic way that gives us our solution to our problem, but it will present how we could find a solution to our problem. So let's take a look at this. Essentially, in order to solve our problem of determining what items to put in the knapsack, what we would have to do is we would have to find every possible subset of the items that we could bring. So we took a look on our previous example that we could bring the phone, hatchet, and raincoat. That's one possible subset of the items that we could bring. We could also return back to where we were looking at that. And that was a while ago now. So we decided items 2, 8, 5, 4, 6, and 1. Okay, whatever those ones were. That is another subset that we could check what the total weight is and what the total usefulness is. Here, where we know that the total weight is less than 30 because we designed it to be, or is equal to 30 actually, and then we calculated the usefulness. We also considered the subset of just items 1 through 4, and we found that it is a weight of 30 pounds or less and has a total usefulness of 27. So we're looking at different subsets of all the items that we could pack. And if we wanted to know with certainty that we found the best subset that we can take, we would have to take a look at all of the subsets. So we would have to check all of the subsets. A lot of them are going to be too heavy, right? We know that if we have all of them, it's 55 pounds. Too heavy, can't bring them all. Okay, cool. Move on to the next subset, okay, or a different subset. So we could take a look at all of the subsets and then say, all right, well, which one is the best? So if we were to do that, and it took us 1 minute to check each subset, add up the pounds. If it's more than 30, move on. Add up, so you move on, add up the pounds. If it's less than 30, you find the total usefulness. Okay, mark that down and move on to the next subset, right? And check all of the subsets. Make sure that they're not over 30 pounds. And as long as they're not, find the total usefulness, and then go back through and choose whichever subset has the most usefulness. But let's say it took 1 minute for every single subset. How long would it take? Well, that just amounts to figuring out how many possible subsets there are. So how many subsets are there? Well, this essentially becomes a problem of, let's see here, the multiplication principle for counting. So what I have is, let's see here, I have a collection of tasks. And what I want to do is consider each item to be a task. And the task is, do I include it or do I not include the item? So item 1, item 2, item 3, item 4, item 5, 6, 7, 8, 9, 10, 11, and 12, because there are 12 items that we could bring for our backpacking trip, right? 12 items that we could pack into our knapsack. And how many options are there for each task? Well, I can either include it or I cannot include it. Those are my two options. So I've got two options, include or don't include. So for item number 1, task number 1, do I or do I not include it? Well, I've got two options, two options, two options, two options, and so on. Okay, for every item that I could pack, I have two options, include it or don't include it. So this gives 2 to the 12, or 4,096 different subsets. That's a lot of subsets. So with that many subsets, it would take, of course, 4,096 minutes to check all subsets. Or, right, translate that into, or convert that into something maybe a little bit more enlightening. That's 2 days, 20 hours, and 16 minutes. Does that seem very reasonable? No, because when I say 2 days, 20 hours, and 16 minutes, I mean non-stop. You're not stopping to eat. You're not stopping to sleep. You're not stopping to simply take a break. That's 2 days, 20 hours, 16 minutes straight. Do you want to check all possible subsets? No. Okay, but formally, this is how we could be 100% certain. And sometimes getting that capability is a little bit unreasonable. Okay, so maybe maybe not a reasonable task to do by hand. You could get a computer to do it. Excellent, right? You'd have to write a program. Wouldn't be too bad, I don't think. But you could do it. All right. So number of subsets. So we looked at a set that has 12 items in it, the items that we can bring backpacking. In general, we would compute or find the number of subsets of any set in the same way. We would say how many items are in the set, how many elements does it have, and then we would either include or not include each one of them. So in a set with n elements, there are exactly 2 to the n, right? Here we had 2 to the 12 because there's 12 elements. So in general, there will be 2 to the n subsets of any given set. All right. So again, there's a lot of subsets. It can be unreasonable to check them all. And we'll take a look at that a little bit more in the next section and a little bit more as we move on through the course as well, right? How reasonable is it to perform a task? Sometimes it's fine, sometimes not so good. And in particular, in the next section, we're going to look at algorithms and their efficiency. And we're going to see how efficiency can change how long it takes, right? There might be a better way to go through all of the subsets, right? Maybe the first thing to do is, well, I don't know what the first thing to do would be, but maybe there's a more efficient way, okay? And we wanted to discuss efficiency and the computation times, that sort of thing in our next section. So these ideas and concepts are all kind of relating together, and they're coming together. So we'll continue on in section 1.4 in our next video. But for now, have a great day.